In this problem, we will determine whether the integral is convergent or divergent, and if it is convergent, evaluate it. Our integral is from 0 to infinity cosine theta e to the negative sine theta d theta. So, by the definition of an improper integral, we will integrate from 0 to t cosine theta e to the negative sine theta d theta, and then we will take the limit as t approaches infinity. I always think of improper integral problems as two steps. First, there's a step where you integrate, and second, there's the step where you evaluate the limit. To find an antiderivative, we will let u equal negative sine of theta, and so negative du will equal cosine theta d theta. So we have the limit as t approaches infinity of the integral of negative e to the u du. Now, I have the bounds that theta goes from 0 to t. Because I don't really want to worry about changing the bounds right now, I'm just going to write theta equals 0 at the bottom and theta equals t at the top. And in this way, I will know that the 0 and t are values for theta and not values for u. We know that the antiderivative for e to the u is e to the u. And then I can replace the u by negative sine theta. And finally, plug in the bounds. So that was the integral portion of the problem. Now we need to deal with the limit portion of the problem. We know that the second term, e to the negative sine of 0, is just 1. Now, imagining t approaching infinity, we know that negative sine t will oscillate between negative 1 and positive 1, which means that the limit does not exist because the exponent, negative sine t, will continue to change as t approaches infinity. So this limit does not exist. That means that our overall conclusion to the problem is that the improper integral from 0 to infinity of cosine theta e to the negative sine theta d theta is divergent.